Hello everyone, welcome to this video. My name is Emerson Ahari. I'm a Google Earth Engine expert. In this tutorial, I'm gonna show you how to do temporal conversion in the Google Earth Engine platform. Most of the satellite data is streaming with a daily temporal frequency, and it is necessary to convert them to weekly, 10 days, or annually, monthly, or different temporal frequency, sometimes based on the target of interest you have for your study area. So in this tutorial, I'm going to show you a very simple and applicable technique in the Earth Engine that allows you to convert the daily or high temporal frequency data to weekly, annually, monthly, or any other temporal version that you need. So first of all, you want to call a kind of satellite data. No difference what kind of satellite data you are working, just one satellite data, preferably with a high temporal frequency, for example, daily one. Go to search places on dataset and find your desired satellite data. For example, I'm going to call Moody's temperature data with daily temporal frequency. So here, just type Moody's temperature products here. There it is. Moody's temperature product available with two different frequencies, daily and 8 days frequency, but I prefer to use the daily data to show that how we can produce such data like the 8 days products, 10 days, or any other kind of products you want to have. Import it into the code, and here you will have an image collection. Now make a variable for the image collection here as, for example, Moody's equals to assign image collection to the Moody's, just like that. In the next step, you want to filter your data based on period of time you want to work in. Here, make a filter date to actually limit your data to a period of time. Now I'm gonna make two different variables as time start and time end, explaining the time the data starts to the time that data ends. So time start, for example, Earth Engine.date allows me to convert a string to the date format. I'm gonna call the data for 1 year, for example, starting from 2023 and ends to 2024. Here, time end equals to Earth Engine.date, just like that, 2024. In the next step, we want to calculate the temporal differences between the time start and time end. Here, I'm going to calculate the time difference, a variable created equals to from time end dot difference, just like that. Allows us to calculate the temporal differences based on between time end and time start based on different units, and you can use different units for this purpose. For example, you can calculate the number of days, you can calculate actually the number of months, or you can calculate the number of years that you have. First, I'm gonna start with the day format because this tutorial can be used for all of the satellite data in the all regions for the world, and also not specifically limited to one region or one kind of satellite data. And using this code, you can convert your data from daily version to any type of frequency that you desire for your work. So here, get a print to see how much the difference is, how many days do we have between time end and time start. As you can see, 365. To avoid any float number, it is necessary to add the run function at the end. The filter date, now the data can be filtered based on time start and time end. No need to any filter bound because we have no framing structure such as Landsat and Sentinel-2 data. Because of that, the Moody's should, for the Moody's product, at least for the Moody's temperature and vegetation products, you can skip the filter bound for this area. And then if you go to the data properties and bands, you can find the target bands. For example, the target band is LSD day with 1 kilometer spatial resolution. Just select the target band using select function and insert the desired band name. Here, make a print from modis variable. In the right panel, you can see we have 365 elements, exact same as the number of days we have, because it has the daily temporal frequency, and for each date separately you can find an image that is LSD day with 1 kilometer spatial resolution. Okay, now I'm gonna show you how you can convert this, for example, to 8 days product or weekly product or different type of temporal frequencies you may need for your study area. So here, first make a list based on number of the days do we have between time start and time end. Earth engine.list.sequence. So list of sequence including different arguments. The first is the start number. We want to have a list starting from a value and ends to another value, starting from 0 and ends to the number that we have for the time difference. Earth engine.number allows us to turn the time difference to the number version. Earth engine time difference here, and the step is very important. For example, the data is already with daily temporal frequency, and now I'm gonna change it to, for example, 8 days product. Now the step should be 8, and as the start number is starting from 0, it is important to subtract the time difference value from 1. And skip the count here, and now get a print to see how list is working. So here we have a list including 46 elements. The 46 elements starting from 0 and ends to 360 based on the time differences do we have between time start and time end. We have 46 elements here because actually the time step, the interval is 8. Now I'm gonna replace each number with the corresponding date. It is very simple technique. You can do it with a loop structure and function. Each input value is an interval explaining the interval or differences between each value that is 8. So here now function returning for each row, I'm gonna have the desired date starting from time start here, return time start dot advance. From time start, I'm gonna go forward based on a delta. The delta already defined through the interval, the values we have here, and the unit should be day because we want to calculate 8 days interval. Skip the time zone here and just print the list again. Again, you will have a list including 46 elements, but this time instead of simple values with 8 days difference, you have actually list of dates starting from origin from January 23 and ends to December 23 with 8 days interval between each date here, as you can see. So now in the next step, we want to make a loop structure actually to filter data based on each 8 days that's already explained here, and then calculate the average, minimum, or maximum image for each period of time we want to have. So here, let's have another variable. For example, I'm gonna calculate modis 8 days, just like that, equals to and here first use Earth engine.image collection to bring whole of the calculation process inside the image collection format, because the input for the calculation is a kind of list that must be converted into image collection structure. So make a map, make a loop structure to actually define the time start and time end for each 8 days, and then calculate and then do the calculation based on the statistical operators. The inputs into the function are including the dates, because we already have the starting dates here, and now in the function body we must define a new time start and new time end for the actually each 8 days interval. So already a start date defined, and we had it already defined by the date. Here the input dates including, you can see them here, and end date is another parameter here. End date equals to, now we can calculate the end dates based on interval do we have and start date. From start date, I'm gonna go advanced just like this based on a delta, and delta is 8 days, and the unit could be days again. Skip the time zone, and here the start date and end date for each period of time settled very well. And now we want to calculate the actually the new temporal frequency, or the new IMG. The new image equals to get modest data and then filter it based on new time start and time end we have. So here, based on a start date and end date, data filtered, and now you can calculate for each period of time, for example, its average or its maximum or its minimum or median value. It's totally up to you and the target of your study, the kind of operator, statistical operator you prefer to use. For example, I'm gonna get the average value with avoiding actually the extreme high and low values. That's why I prefer to use median instead of average. So the median for each 8 days calculated here, and finally the function returned the new converted images with the new system time start variable. As the temporal frequency changes, now we want to have the new properties explaining the actually the date acquisition or date creating or date of each image. So a new system time start created, system time start equals to here equals to a start date with millisecond format. So, and now I want to have a new system index that's showing start date with a string with a normal format or the date format, as you can see here, because the millisecond format is only usable for the Earth Engine data analysis. But as a user, if you want to interpret the date, it's a little difficult to use the millisecond format. That's I'm suggesting to have the start date, the system index with a normal format instead of millisecond version. For example, I'm gonna see the date actually structure with this format: year, month, and date, just like this, and print modest 8 days, just like that. Run it in the right panel again. 46 elements returned because we already had 46 dates with 8 days interval for 1 year. Now you can see one image calculated for each date that's showing the LSD with two properties. One of them is the system index, and another one is actually here. Another one is system time start with the millisecond format that can use for the other kind of studies and also further processing. So here, for example, I can select a point and calculate and compare the 8 days and daily data next to each other. So now I'm gonna have a new chart. User interface .chart.image.series allows us to actually show the temperature variation, land surface temperature variation for the selected point here. Instead of image collection, I'm gonna have the modest. First, I'm gonna have the modest daily data for the region of interest. It is a point already defined by a geometry. And now the reducer or statistical operator explaining what kind of value can be plotted in the chart here could be the first value that is detected by a marked point, Earth Engine dot geometry dot here Earth Engine dot reducer dot first is a kind of function we want to use to highlight the temperature variation, and the scale should be 1000 meter, explaining the actually related to the spatial resolution. For example, the spatial resolution is 1 kilometer. That's why we want to have a scale with 1000 meter. So X property explaining the date acquisition, system time start, and run a code. In the new chart in the right panel, you can see the temperature variation with daily frequency, as you can see highlighted here. Now you can try again this function, this time for the 8 days product. Again, here you will have modis with 8 days frequency. For the same area, you will see the temperature is available with 8 days interval. For example, March 22, March 30. And here we have June 2nd, and this here we have June 10th. And exact, you can see you can see precisely we have actually converted data from daily frequency to the 8 days. And now you can change this code for different temporal frequencies. Imagine that now I'm going to use this code for 16 days interval instead of 8 days. So now have a look on the code to see what kind of parameters should be changed. The time start and time end remain same, and the time difference still we want to calculate as long as we want to calculate 16 days interval. The time difference should be calculated based on the days. And also here we will have we had a list. The interval number was 8. We can also have another variable as interval, or we can have delta. For example, we can have another parameter as delta here equals to Earth Engine dot number. This time, for example, 16, and you must look into the code, and where you entered the value, any value regarding to the 8 days should be replaced with the delta here. For example, instead of 8 days, 8 step, we will have a delta here, and again, and instead of 8 days, we want to have delta again here. And now the problem is solved, and the code will return actually the data with 16 temporal frequency. Remember to save your code and run it again. So for 1 year we have 365 days, and we have only 23 images with 16 days interval. As you can see here, this image is for February 2nd, and the second one and the next one is for February 18. Well explaining the 16 days interval between each data. And also it is very simple to use any other type of statistical parameter. For example, most of the time you may prefer to use mean instead of the median, or may you want to prefer to use, for example, the maximum temperature detected for each period of time for each pixel separately. It's totally up to you the kind of a statistical parameter you want to use. Or maybe you want to calculate the standard deviation, for example, Earth Engine reducer. Here you can use the reduce function, Earth Engine reducer standard deviation. Here you are calculating the standard deviation for each 16 days for each pixel in the image or the selected point here. Or maybe you want to have, for example, the percentile, Earth Engine reducer percentile. For example, I'm going to calculate the percentile, for example, 75 for percentile 75 for every 16 days. The type of statistical parameter you're going to use for calculation is totally up to target of interest and the kind of interpretation or your expectations from the study. And here there is an open area, actually structure platform in the Earth Engine for the users, enables you to do various actually type of analysis and get a different type of information regarding to the kind of work you want to do it. So, and let me to back to the average method again, using the median, just like this. One parenthesis was extra and remove it, and here now we have it with the 16 days format. Now imagine that I'm gonna calculate the monthly variation. So here the unit, instead of month, the unit replaced with the month. Before we had days, because the target interval was 8 days or 16 days, but now I'm gonna do calculations based on the number of months that we have between start and end. So here I'm gonna have a 1 month interval between each image in row, and here you can see the delta turn to 1 and the unit change to months. Instead of days, we must have months in the code. So we will have 12 months and 12 elements, and here you can see the first image for January 1st, the second February 1st, the third is the March 1st. And this is how you can do conversion for the number of the months. Or if you want to get it for each 2 months here, you must change the delta to 2. As you can see, we have 6 elements with 2 months interval. First for January 1st, second March 1st, a 2 months interval between each image we have. Or even you can change the time start and time end. For example, I'm gonna do this for a longer period of time. I'm gonna have monthly temperature from 2010 to 2024, just like this. Just run a code with 1 month interval and for a longer period of time. And remember to save your code here. You can see July, August, September, October. You can actually see the variations with monthly. But here for the daily data, you got the error because the error is related to the calling more than 5,000 elements. That is normally happen, but no problem. We already turned to the monthly version, and the monthly version actually visualized here. Or even maybe you want to have it with annual frequency. Here I changed to the year. You can see just very simple and few parameters should be changed, and you can keep other parameters same. So here the unit changed to year, and run a code. We have 14 years from time start to time end, and here you can see the average temperature value from 1 year to another year. January 2014, January 2015, January 2016 with 1 year interval. Yes, there it is, and you saw that how we can do temporal conversion in the Google Earth Engine platform. I hope you like this tutorial, and if you had any question or problem regarding to the temporal conversion, just feel free to put your comments on my YouTube channel. I will be happy to answer your questions as soon as possible. Thank you for your attention, and please share the tutorials with your friends and community.